This video is about integer rules for signed numbers. The key idea is that there are different rules for addition and multiplication. You might ask, what happened to subtraction? What happened to division? Subtraction is a special case of addition because it's an inverse operation. In the same way, division is a special case of multiplication. For the same reason, it's an inverse operation. Both of these operations can be expressed as their inverse by employing the idea of either the additive inverse or the multiplicative inverse. So these are the rules. These are the addition rules. Change, subtraction to addition. Okay. So, use these rules for addition of signed numbers. Check the problem. If they have the same sign, then the same sign in the answer, and you add. For example, I have maybe -6 plus -8. Notice they're the same sign. That means I'm going to have a negative in my answer. I add 6 plus 8, 14. I might have 2 plus 3. Both are positive. My answer will be positive. 2 plus 3 is 5. Number 2, different signs. Then I find a difference. That means subtract. The answer will have the sign of the greater absolute value. For example, I have -6 plus +8. They have different signs. Because they have different signs, I know I'm going to be finding a difference. 8 has a greater absolute value than -6. 8 is farther away from 0 than -6 is. So because 8 is a positive number, my answer will be positive. 8 minus 6 is 2. Positive 2. If I were to model this, it would look like this. 1, 2, 3, 4, 5, -6. Plus +8. 1, 2, 3, 4, 5, 6, 7, 8. I have 6 zero pairs. That leaves me an answer of +2. Maybe I have this situation. Maybe I have a 10 and a -12. I have two different signs. I know my answer we'll take the sign of the number with the greater absolute value. Negative 12 is farther from 0 on the number line than 10 is. So my answer will be negative. And then I find a difference between 12 and 10, which is 2. If I were to model that, it would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, positive 10, and negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 10 zero pairs, leaving me negative 2. Those are the addition rules. Now, we also have multiplication rules. Multiplication rules. This applies to division also. Division is a special case of multiplication. So, count the number of negative signs. If there is an even number of negative signs, the answer is positive. If there is an odd number of negative signs, the answer is negative. For example, negative 1 times negative 1 is, now if I just apply the rule, a negative times a negative is positive 1. And it makes sense because this is saying, what is the opposite of negative 1? Positive 1. If I have negative 1 times negative 1 times negative 1 times negative 1 times negative 1, the opposite of negative 1 is positive 1. The opposite of negative 1 is positive 1. And then I have a negative 1 left over. Positive 1 times positive 1 is positive 1 times a negative 1. This means take the opposite of that one, so my answer is negative 1. That can be a little confusing. It's helpful sometimes to have a model for this one. So let's say I have negative 2 times 4. This means, first of all, I think I have two groups of 4. So here's one group of 4. Here's another group of 4. This means take the opposite of that. So these all change. 1, 2, 3, 4. 1, 2, 3, 4. My answer is negative 8. Maybe I have a problem like this. Negative 3, negative 2. Negative 3 times negative 2. I start out like that. I have 3 groups of negative 2. So there's negative 2, and negative 2, and negative 2. This means take the opposite of that. So these change to, which is positive 6. So in this case, I had one negative sign. My answer ends up being negative. In this case, I have 2 negative signs. My answer is positive. I hope this was helpful. Please let me know if you need more help with this. Thanks.